Welcome to the latest in CAE's e-learning webinar series. My name is Mike Curon, and today we'll be talking about ANSYS workbench meshing. A few administrative items to cover before we get into the topic of meshing. We'll be offering continuing education credits in New York only. Now, in order to do that or qualify for that, you'll have to participate in the polls and the follow survey that we send. So if you're interested in those credits, then certainly make sure that you participate there. And for everybody else, we certainly appreciate your feedback and help us out for future webinars. One more thing, there is the chat window. You can send in any questions you have while I'm going through our my material today, and hopefully at the end we'll have a little time to go over those. If not, I'll get back to you later. Let's get started. Let me open my PowerPoint here, make sure we're looking at the right thing. What we're going to go over today is ANSYS workbench meshing, and specifically solid meshing within ANSYS workbench. And topics that I plan on covering, foremost, why you want a brick mesh. So if in workbench meshing, you're creating a solid element, why would you want to generate a brick mesh? Second, if I convince you that that's exactly what you want to do, how do we go ahead and do that in ANSYS workbench meshing? So we'll show a couple of different methods that are used in order to create bricks. Finally, I'll do a live demonstration on a part that I'll show you how I go about my method for going about creating brick elements using workbench meshing. Okay, so how do I get a brick mesh? And before we even get to that, why do I want a brick mesh? Well, the reason you want a brick mesh comes from basically the shapes of the elements. So 3D elements generally come in a few basic shapes. We have our hex element all the way on the left here. We have pentahedrons, which are wedges, prisms, or degenerate bricks. And we have tetrahedrons, which we can see all the way on the right. Now, using tetrahedrons is very easy. Most meshing modules will have, very easy inputs to create a mesh, and you can generally fill any arbitrary volume of tetrahedrons with very limited user input and difficulty. Now, with pyramids, these are less common, but anytime we have a mix of tets and bricks, then we're going to need to also have pyramids to transition from one shape to the other. So why is it that we want to use hex elements predominantly? Well, one of the major reasons is that hexahedrons can fill a given volume, so any arbitrary part that you may be analyzing, more efficiently than the other mesh shapes. So if we look at it, it takes approximately 5 to 6 tet elements to fill one brick. And the result of that, if we have more elements, then we have more nodes. If we have nodes, then we have more degrees of freedom that we have to solve for. And our solution time is going to take longer with tet elements. For the resolution of our solution fields, our degree of freedom fields, we're going to have to take significantly more computational expense using tet elements than we would with hex. Now, the reason we would like to use hex elements is that they're generally more uniform, and we can control the element distribution on a finer level. So for hex meshing methods, we often have a much greater control over, let's say, the number of elements in a certain span, how those elements go and vary. So there's a lot of different control that the brick elements afford us. Now, to convince you that brick elements are the best thing going, what do you need to take in order to generate a brick mesh? Now, the unfortunate truth is that brick meshes always take more man time than tetrahedral meshes. Take user input. So on the pre-processing end, you'll have to certainly give more effort. But hopefully, if you're doing anything that's computationally intensive, it'll save you some time on the solution phase. Solutions are usually created using one or more of the following approaches. We take arbitrary part and we slice and dice. So basically what we're doing is subdividing our geometry so that we create 6-faced volumes that we can then use a sweep method to create brick meshes within. So for space volumes, we create a 2D mesh of quadrilaterals and sweep them from one side of the volume to the other. And operations like this include revolving the mesh about an axis, like we see down here, and the mesh along one or more curves, or swing from one face to another in a topologically similar fashion. These are all covered under the sweep method in workbench meshing, but also other methods that can create bricks. And these are more advanced algorithms, for instance, the multi-zone method. I'll show you that in a little bit. So if you're not convinced yet that meshing is what you want to do, let's consider the part that we have shown on the screen here. We have a generic part here that's not sweepable in its present form. You see, we have a single source and a single target face and a smooth path between the two. So by default, be able to create a brick mesh with a sweep method. However, a little bit of effort by the user, we can create a very uniform, controlled brick mesh. So let's take that. Where is I've gone back from workbench meshing into Design Modeler and did a number of slices and form those resulting bodies into a multi-body part. We have a collection of sweepable bodies. See that we get a very nice uniform mesh. The restriction that I've put on this mesh is that we have 3 elements to the thickness of the thin walls. Again, an arbitrary constraint, but it is something that I use in this instance to show that you can control this. It can be anywhere from 1 to as many as you'd like. And the result that we get here is a higher order mesh that we have 8,000 elements and more than 42,000 nodes. So pretty good. I mean, if we look each of these bodies with different colors or the individual bodies, we have a continuous mesh through the whole thing. We have a pretty efficient mesh that we've generated. Take a look alternatively at our options for just going ahead and tet meshing this body without doing any of the work to get a brick mesh. What result be there? For the resolution using tetrahedron elements, and we're enforcing the need to have 3 elements to the thickness of the thin walls, I was create this mesh with very little effort. So I didn't have to do really anything. I just had to wait for the mesher to do its work. Rather easy on my end, but the result of that is now I have 84,000 elements and over 130,000 nodes. So I get 3 times the number of nodes, and obviously that's going to influence the computational expense. So I think here we can see the benefits of taking that extra little effort on the pre-processing end to maybe do a little slicing and dicing and create a brick mesh. At this point, what I'd like to do is take a brief pause and open up our first poll. And that poll is going to be on the percentage of time that everyone spends using during a particular analysis. Certainly appreciate your feedback here. Just sum that up, and we'll take a minute to get everybody to contribute. Okay, we have a couple people that are just finishing up now. It looks like almost everybody's participated, so we certainly appreciate that. Let me just wrap this here, and we can open the results. And kind of what I would expect is that it looks like you guys are spending usually a rather significant amount of time in doing your meshing. Certainly it's an important part of the the analysis process, and it will be important, for you guys to make sure that concentrate on doing that efficiently and creating brick elements. Let me just make sure I save this and continue on here. Let me go sharing my desktop. And so now the benefit of a brick mesh, you're probably wondering, how do I go about getting that brick mesh in Workbench? And there are several different methods that we can use within Workbench meshing in order to create a brick mesh. We have the method, the hex dominant, and the multi-zone, and certainly it's important to understand that each of these has different geometry requirements. So let's make sure we know that, and it's important to understand that so we know how they behave. In fact, if I can't get a mesh that's entirely bricks, a lot of times for any part that they're analyzing, I'm sure most of you are not just analyzing bricks, otherwise you wouldn't be really breaking too much ground. So arbitrary, complicated part, we may not be able to fill it entirely with bricks. So what we're going to try to do is fill it as much as we can with bricks, and then fill in the rest with TETs. And that's where techniques called selective meshing come in, where we can control the mesh on a fine level, body-by-body basis. The sweep method, the requirements here that we have a topologically consistent source and target face. And what that means is that we have the same number of vertices per face with a smooth path from the source to the target. So if we take a look back at our part here, we can look at the bottom cylindrical face here, and we see we can sweep from this outer radius to the inner because we have exactly the same topology on both faces, and we have a smooth path from one to the other. Sweep mesh is the default Workbench meshing approach, so it will automatically try to mesh any box with bricks if it fits the topological requirements, and if it doesn't fit those requirements, then it'll just fill it with tetrahedron elements. Even though this is the default, there may be instances where we want to go ahead and insert a sweep method manually. And the reasons that we may want to do that are to specify manual source and target faces. So do that in manual fashion rather than having Workbench detect them automatically. Some is where that may occur if you have more than one possible sweep direction and you want to control the mesh in a specific manner. If you sweep a mesh as a thin solid, so it only has one single element through the thickness, certainly a manual method will let you do that. If you want to inflate the mesh near the surface of the geometry, let's say, for instance, you have a stress concentration, that can certainly be useful for bunching elements in those particular areas. The control that this affords us by manually specifying the sweep method is that we can set the number of elements in the sweep direction as well as bias. So we can clear elements in certain areas and set exactly the control we want over the generation of the brick elements. So a very powerful technique here, but does require a specific type of geometry to be present, and that's where the slicing and dicing comes in. Our automated methods, the first of which is the hex dominant method, don't require the slicing and dicing, and are kind of doing the same thing to create bricks, but in a behind-the-scenes fashion. So what the hex dominant method does is creates a primarily quadrilateral mesh on this outer surface topology and sweeps that inward. So it'll try to create as many hex elements as possible, and then internally fill those areas where it can't create hex elements with wedges, pyramids, and tet elements. The hex dominant method is particularly useful for bodies that we have high volume to surface area ratio. So if you have big, chunky parts, you have a lot of interior volume, the hex dominant method will be particularly useful. It won't be useful for thin, sculpted parts just because of the nature of the algorithm. Once we use the hex dominant method, a neat little trick that we can do is come down into, if we highlight mesh in the outline tree and come down to the bottom of the details pane, you see we have the statistics, And if we list, let's say, the element quality mesh metric, we can see what types and roughly how many elements of each shape are created. So it gives you a guide as to bricks you're creating and how efficient the hex dominant method is behaving. If you want a detailed look at that, you can always go into FE Modeler. Now, it is the multi-zone method. The multi-zone method, and we'll show you this during our live demo, is an advanced algorithm that uses the hexablocking method, of ISOM, and that internally tries to do the slicing and dicing you'd otherwise manually do in Design Modeler. So it'll create, based on the geometry, regions where it has topologically consistent pieces, and it can create elements by doing a sweep. It's a powerful method here, and we'll show you how that works in our demo. Now, the thing about workbench meshing is that we have different meshing algorithms and meshing methods, and we can combine those in any manner that we see fit. So for a given multi-body part where we want a continuous mesh, we can combine any different number of meshing methods. You can see in this one we have a sweep method on this top hook region. We have a multi-zone on the bottom plate region, and we have a tetrahedron method in the middle chunk there where we're able to generate bricks. So interchange all these different methods for a multi-body part, without any difficulty to create the most efficient and highest fidelity mesh possible. Now, one last thing that I wanted to note on workbench meshing before we go to the demo is a feature called selective meshing. Now, selective meshing for multi-body parts allows us to dictate the order in which the mesh gets generated. So in this particular multi-body part, we have 4 bodies. What we can do is say that, instruct the mesher that we want to mesh this base plate first, and then the outer ring, the hook, before we go ahead and create the tetrahedron elements. So this is the existing mesh that you've manually told workbench meshing to generate to influence the mesh that's going to be generated next. So very powerful tool here. The way that we do this is by right-clicking on bodies and say generating mesh on that particular body. And if you're going to do any parametric studies, you can also record the order in which you mesh the different bodies. So that'll be persistent when you do any parametric updates. Now, it's introduced in version 13 and was called direct meshing in version 13, but is now called selective meshing in version 14. So a little bit of change, but the same idea, and has been available since then. Okay, at this point, let's take another brief pause and do our next poll. We'd like to get some input on how many of you are using workbench meshing versus maybe some other tools for mechanical APDL. So let me go ahead and open that one up, and we'll get your input over the next minute or so, and we certainly appreciate that. Okay, looks like most folks have finished that up. Just another couple people. And looks like we're wrapped up there, so let me finish that. Make sure we show. So it looks like a lot of, a few people are using Workbench, maybe 50% of you, and we have some people using APDL. Hopefully we can kind of benefits here, and the use of workbench meshing. I save these results here, and we'll go on now to the live demo portion here. Share my desktop again. So let's look now into Design Modeler. We have this part C in Design Modeler where it's a big hook part with a base plate, and what we can see is that this is not in its current state ready to be brick mesh. So we can't just sweep it. We'll have to either use one of the advanced algorithms or use do some slicing and dicing to create a brick mesh. Now, one of the things I'd like to point out here is that if you're unsure, or if you think maybe something is sweepable and you're not sure whether or not it is, a really neat feature in workbench meshing is we can right-click on mesh, and we can go to the Show submenu and say Show Sweepable Bodies. Or in this instance, nothing gets highlighted because we don't have any sweepable bodies. But in the event that we do, and I'll show you this shortly, what workbench meshing module will do is highlight any bodies that are sweepable in green. So it's really easy visual cue to see if you do have sweepable bodies. And often this is important, particularly if you have complicated CAD parts where you're slicing and dicing and you may have small features that you miss. Ultimately, it's more important that workbench meshing thinks it's sweepable rather than you, and it can help you diagnose where you have difficult geometry. So to Design Modeler, what I'd like to do is show everybody how I would go about creating a brick mesh with this part. Now, what I would preface this with is creating a brick mesh and doing this slicing dicing technique is very much a personal approach to how you would decompose geometry. So if I give this part to 5 different people, I can almost guarantee that I'd get 5 different geometry subdivisions and 5 different meshes in the end. So there's a right way, but what I'll try to do today is show you guys how I go about doing this. I'll give you some clues into the process that I go through. So the thing that I want to do is, this part is very pretty symmetric. So what I'd like to do is cut it in half, and we'll say, for argument's sake, that this is going to be symmetric loading as well. So first create a plane here, and I'll create it from this face so that I can just offset it, so it's in the middle of the hook there. And what I'll do is, I already measured this, so I know the difference here. 375, and let me just flip the C there. Okay, I have this plane right in the middle of the hook, and what I'm going to do is go to the Tools menu and Symmetry object. Now, the object serves 2 functions here. One, it's going to use this plane, the plane that I just created, in order to cut the model right in half. Now, it's also, once we go back into mechanical, going to tell me it's going to automatically apply the appropriate symmetry conditions. So it's really powerful tool here, something that hopefully everybody's aware of. As I generate this, you'll see now I've got my model, and once we go to mechanical, you'll see those boundary conditions. Now, the first step in my slicing and dicing, what I want to do is separate this base plate from the chunky hook region. So the way I'm going to do that is select these edges here, right around the joint, the in which the base plate meets the hook region. And I'm going to highlight those edges and then go to the extrude operation. So those edges as the base object in my extrude, I can create a slice, and what I do here is slice down through the base plate. So I select this edge that represents the correct vector along which I want to slice those edges, and make sure I slice that all the way through. So that I generate, you see 2 different parts here. So this slice in particular doesn't get me all the way to having sweepable bodies, but it sets me up for my next slice, which will then create 2 additional sweepable bodies. So it's kind of a preliminary slice. What I want to do is slice against the base plate and cut off this rounded edge region. To select one of these edges, and an easy trick here is that I can extend my selection, in this case to the limits, that'll select for me all 5 edges along this fillet on the edge here, which I can use as the base object for another extrusion. So it's over to a slice. Again, I slice down through the base plate, and it goes all the way through. All right. Now you have 3 bodies in my model. On the base plate, I now have 2 sweepable bodies. So this one, the main area here, is very clearly sweepable, where I have a top face and a bottom face that look that are topologically exactly the same. But on the outside, however, may be fleeting. It may not look exactly like it's sweepable. But it is actually sweepable because I have the same here as I do on the other end here, and I can sweep it all the way around the outside. Definitely, definitely 2 sweepable bodies here, but I have this chunky part up here that's not quite sweepable yet. What I want to do is create one more slice, and I select this edge here. And what I do is use that as a base object for a slice. And this time I'm going to sweep it out along the Z direction. It goes through that entire hook geometry. So now I have 3 sweepable bodies, and I have one last body that's not really sweepable. Maybe I could create some more cuts, but for the purpose of this demonstration, this will suffice to show what we're getting after. Now, the last thing that I want to do is make that I form all of these 4 bodies into a multi-body part. So I want to select them all, click and say Form New Part, and that's going to ensure that once I go over to Workbench Meshing, that it's a continuous mesh through all 4 of these bodies. Go back to the project page. Bring that over, and click on the model, refresh to read in the new geometry. You see it so that I have the symmetry meshing that I have in Designer. Now the symmetry conditions, region here where I use the symmetry tool. Symmetry shows I have a multi-body part, and click on meshing. Show exactly what I thought when I was doing the slicing. I have 3 sweepable bodies. So let me click and generate the mesh, and you'll see the automatic method, real quick, will go through and sweep the bodies that it can, and then fill in tet meshes everywhere else. What you see is I get a really nice, uniform, swept mesh with really limited effort. So that took me maybe all of 2-3 minutes to do those slices. So really not a whole lot of effort. And from here, what I could do is go ahead and insert any type of different controls to get even more local refinement to tailor my mesh. Okay, so let's take a brief pause and do our last poll. And the last poll is going to be a little information on how we how you guys are experiencing meshing. What's your biggest bottleneck? So we'd like to get some feedback there. Just to note, looks like we are going to run over just by a few minutes, but you can stick around and see us do the multi-zone meshing. So let me up this poll here and try to get some of your feedback. Like most of you have participated. A few people wrapping up here. Your input. A couple more seconds. Okay, great. So we have a wide array of different concerns here. in terms of holding everybody up, and that's kind of to be expected. There are a lot of things that go into meshing. Kind of depends on what type of geometry you're using. But certainly learning more about the Workbench meshing tools should help you guys out. Last thing that I want to show you before we wrap the webinar for today is the multi-zone mesh method. Bring that over into screen here. You can see done is suppressed all of the extrude operation, so I got rid of all the slicing and dicing that I did, but retained the symmetry just for to make it a little smaller. So if I want to create a multi-zone mesh, what I do is I right-click on the mesh folder, insert method, and scope to the appropriate body, and I change that method to multi-zone with a number of different options under multi-zone. Now, the mesh type dictates what type of mesh it's going to try to map over the surface of the body. Free mesh type is going to be what type of elements it's going to create on the interior. So if you set free mesh to not allowed, basically what that's going to do is make the meshing method fail if it can't create all brick elements. Now, some other options, you can have it create tet elements in between where it can't create bricks, or other methods such as hex dominant or hexacore. There's some different options based on what type of elements you'd like it to allow the meshing method to create. To hexacore for this particular part, and just use the global size settings. And let's go ahead and generate the mesh just to see what we get. And what I suspect we'll get is that we'll get a nice hexahedral mesh on the outside, and a great deal of brick elements for this part with relatively little effort. That's exactly what we get. We get a nice looking uniform brick mesh, and if we wanted to, we could go ahead and use more local controls and a even higher, more predominantly brick mesh using a smaller size element. Okay. So now, today, brick meshes are more efficient and more controllable. Again, we have a great more deep level of detail creating brick elements, and they're much more computationally efficient than using tet elements for the same resolution thing. This Workbench allows us many different options for generating a brick mesh, and the ease of use of ANSYS Workbench makes generating these brick mesh more streamlined, simpler, and easier on the user. So a lot of different options here, and hopefully you guys can go ahead, go out there and use them on your parts. We've run over, so what I'm going to do is any of the questions you guys submit, I'll follow up with you via email afterwards. But thanks again for the input, and I appreciate you attending today, and hopefully you got a little bit out of it.